In this video, I'm going to go over a vast majority of the fall semester cumulative review even problems. So we'll start with problem number 2. It's an absolute value problem. We've got some things to do before we figure out what case we have to do with the absolutes. So I'm going to subtract the 1, negative 2, absolute value x plus 7 is greater than negative 10. Now, I'm going to divide the entire equation. I'm going to divide by negative 2, both sides. Now, remember, when it comes to inequalities, when you divide by a negative, you flip the sign. So I'm left with absolute value x plus 7 is less than positive 5. Now I make a determination as to what do I do. Since it's an absolute value less than, I'm going to make a less than sandwich. I'm going to put negative 5 on one side, so negative 5 is less than x plus 7, which is less than positive 5. Now I'm going to solve both sides simultaneously by subtracting 7 to get x by itself. And my answer is negative 12 is less than x, which is less than negative 2. Which means my solution is a bounded region. Okay? All the values between negative 12 and negative 2 act as my solution. So if they wanted a graph of that, it's going to look like this. I'm going to put negative 12 on one side. I'm going to put negative 2 on the other. And they're going to be open circles. And it's all the x's that can be found in between those two values. Okay, the next problem. Solving for this problem. The first thing I'm going to do is distribute the x. So that would be x squared, and that would be minus 2x. Plus 10 equals 0. Now, if that could be factored, I would factor it, but it isn't. It is not factorable. So I'm going to have to use the quadratic formula, which I've written right there. I'm going to use the quadratic formula. I'm going to plug in the values of a and b and c. So x equals the opposite of the b value, so that would be positive 2. Plus or minus the square root of the b squared, so negative 2 squared would be 4, minus 4 times a times c, so it would be 4 times 1 times 10, which is 40, all over 2a, 2 times 1 is 2. So x equals 2 plus or minus the square root of negative 36 all over 2. Now the square root of negative 36 is 6i, so 2 plus or minus 6i over 2. Now remember, that denominator of 2 is under both the 2 and the 6. So when I reduce using that 2 down there, 2 over 2 becomes 1. But 6i over 2 becomes 3i. So there's your answer right there. 1 plus or minus 3i. Okay, problem number 6. Another solve problem, and it has a square in it, but this time we really don't have to do any distributing or anything, because we're going to ultimately solve this problem by getting rid of that square by taking the square root. So my first step is going to be subtract that 7, and I've got 1/2 x minus 3 quantity squared equals 6. Now my next step after that is going to be get rid of that 1/2 by multiplying both sides by 2. Easy enough, because 2 times 1/2 is 1, and so now at this point what I've got is x minus 3 squared equals 12. My next step is the square root step. And what I'll be left with at that point is, I'll go this way, what I'll be left with at that point is x minus 3 equals plus and minus 2 root 3. Because that's what the square root of 12 is. Now I've got one more step to do, and that step is add the 3. And so my final answer is x equals, I can't just add the 3 to the 2 square root 3 because they're not like terms, so I'm just going to squeeze it right in there. X equals 3 plus or minus 2 square root 3. And there's your answer. Okay, on to problem 8. Problem 8's a factor problem. Okay, there's no equal sign, so it isn't a solve. I do have a GCF, and that GCF is x. So I'm going to factor out the x. I'm going to be left with x to the 4th minus 7x squared minus 18. Now I can factor this. Okay? There are factors of negative 18 that add up to negative 7, and that would be negative 9 and positive 2. Okay? So I would, don't forget about that GCF of x. It's gonna come in our final answer. So the first term of the trinomial is x to the 4th. So I would need an x squared right there and an x squared right there. Now we already know the factors of negative 18 that have a sum of negative 7 is not minus 9 and plus 2. So let's don't forget that x. So we're almost done. X squared minus 9 is a difference of perfect squares. So we can take this one step further, and my final answer would be x times x plus 3 times x minus 3 times x squared plus 2. And that would be my fully factored final answer. On to problem 10. Factoring a sum of perfect cubes. We recognize 125x cubed as 5x to the 3rd power. And we recognize 8 as 2 to the 3rd power. So now you have what I call the players in the game, or the A and the B. Now when you follow the sequence, when you factor a perfect cube, you're going to have a smaller factor of a binomial, and you're going to have a larger factor of a trinomial. So I make a small set of parentheses and a large set of parentheses. We use the acronym SOAP to guide us in the signs. Same, opposite, always positive. So since the problem was an addition problem, same is plus, opposite is minus, always positive is always positive. Now, the terms we put in the binomial, it simply represents one of each of these terms. So I'm going to put a 5x right there and a 2 right there. Now when it comes to the trinomial, the pattern of the trinomial goes, it starts with 2 of these. Okay. And then the middle term is 1 of each, and then the last term is 2 of those. So 2 of these, 5x when you square it is 25x squared. The middle term, 1 of each, 5x times 2 is 10x. And then the last term, 2 of those, 2 squared is 4. And that's your factor of that sum of perfect cubes right there. Okay, problem number 12 is we want to factor the problem they gave us. I didn't rewrite the problem they gave us. Knowing that 2 is one of the zeros of the function. So, long story short, it's going to be, we're going to use synthetic division. So, there's my 2. Okay. And then here are the leading coefficients of the 4-term polynomial. So, synthetic division starts off with, you just rewrite that first leading coefficient, which would be 1. And then 2 times 1 is 2. And then you add, you combine like terms. 4 plus 2 is 6. Okay. 2 times 6 is 12. Negative 39 plus 12 is negative 27. 2 times negative 27 is negative 54. 54 plus negative 54 is 0. So remember, that's the remainder. So right now, we knew that 2 was one of the zeros all along. So one of the factors would be x minus 2. That's the one we knew all along. If 2 is one of the zeros, then x minus 2 is one of the factors. Now the rest of the polynomial is x squared, because that's a 1 right there. So it would be x squared plus 6x minus 27. Now the next question is, can this be factored down some more? And the answer is yes. The factors of negative 27 that have a sum of positive 6 are 9 and negative 3. So all of my factors are x minus 2, and then this one becomes x plus 9 and x minus 3. Moving on to problem 16. I have a rational expressions problem, ugly fractions. I'm subtracting 2 ugly fractions, so I need common denominators, but you can see right off the bat I do have common denominators already. So the hardest part of the problem has already been fixed. I have common denominators. Now notice it is a subtraction problem, so I'm going to distribute that subtraction sign right off the bat so I don't get caught. So that means the subtraction is going to change to addition, and these 2 terms are going to become their opposites. So since they're both positive, I'm going to make them both negative. So that makes the addition now fairly easy. I know what the denominator is going to be. It's x squared plus 4x minus 21. Now, what's the numerator going to be? Well, let's start combining like terms. What's 7x plus negative 5x? And the answer is 2x. And then what's negative 2 plus negative 4? And that would make negative 6 or minus 6. So in its raw form, that's my answer right now. But I can clean it up by factoring and canceling whatever I can. So on the numerator, I can definitely factor out a 2 as a GCF, and I'd be left with x minus 3. And on the denominator, the factors of negative 21 that add up to positive 4 are x plus 7 and x minus 3. And now you can clearly see what happens. Those two x minus 3's can cancel each other. And so our final answer is 2 over x plus 7. For problem 18, I have another rational expressions problem. It's another subtraction problem. And again, I have common denominators, which is really nice because I already know my denominator is going to be x minus 7. The big question is, what's the numerator? So I'm going to distribute the negative sign again. Subtraction is add the opposite, so the subtraction sign is going to change to plus. And I'm going to change both of these numbers to their opposites. So since they were both positive, they are now both negative. So the numerator is going to be 9x plus negative 4x, which is 5x. And then the integer, the constant, is going to be 3 plus negative 5, which is negative 2. And so that's my answer to that problem. Okay, problem number 20. I just have a single rational expression and it needs to be simplified. So really it's just a matter of factor and cancel. Now, the denominator is going to be a little bit easier because it's one we're more accustomed to. It's just your regular old trinomial with a leading coefficient of 1. So the factors of negative 35 that have a sum of negative 2 are x minus 7 and x plus 5. Now the numerator, on the other hand, it's a guess and check. Now the first term is pretty easy. There aren't that many ways to achieve 3x squared. It's basically 3x and x. Now on the back end of this, we have negative 20. So we've got all these combinations. How do we get 20? Well, 1 and 20 would work. 2 and 10 would work. 4 and 5 would work. So we're going to try the two closest to each other, which is always the first one to try. So we're going to try the 4 and the 5. Knowing that I have to get negative 20 means one of these has to be negative and one of them has to be positive. So it's called guess and check, so you kind of have to play around a little bit, and what you wind up finding out is in order for this to work, I need to put this as minus 4 and I need to put that as plus 5. Now it's called guess and check, so the only way you would really know if it's right, you would have to FOIL this out, but you are going to get 3x squared plus 11x minus 20 when you FOIL this out. And now that you have it all factored, you can clearly see that the x plus 5's cancel each other. And so your left is your final answer, 3x minus 4 over x minus 7. Okay, so now for problem 22. I want to find the x-intercept and I want to find the y-intercept. So in order to find the x-intercept of this, if I graphed it, what would be the x-intercept? You set y equal to 0. Well, y is right here. The function equals y. So this is where your 0 would be. 0 equals 1 over x minus 4 plus 2. Your next step would be take the 2 over to the other side with a subtraction of 2. So we'd have negative 2 equals 1 over x minus 4. Your next step would be cross multiply. So negative 2 times x is negative 2x. But you also have to cross multiply the negative 2 with the minus 4. And you'd get plus 8 equals, if you cross multiply that way, 1 times 1 is 1. So now the next step, subtract 8 from both sides. You'd have negative 2x equals negative 7. Divide both sides by negative 2 as your final step. And you'd have x equals 7 over 2, or 3.5, or 3.5. So if we graphed this, this is where the graph would cross the x-axis. Now we're going after the y-intercept. So for the y-intercept, we need to set x equal to 0. So that x right there needs to become 0. And we'd have the equation y equals 1 over negative 4, because 0 minus 4 is negative 4, and then plus 2. So y equals 1 over negative 4. Positive divided by negative is negative, so think of that as just negative 1/4 plus 2. And negative 1/4 plus 2 is 1 3/4, or 1.75. And that is the location of the y-intercept. If you graphed this, it would cross the y-axis right here. I've done a few steps already for problem number 26. You can see here's the original problem up here. And it is a rational equations problem, not a rational expressions problem. It has an equal sign. So the idea is the denominators are going to go away. We just have to know what makes them go away. So I need to understand what x squared minus 2x minus 15 is made up of. So the next thing I did was I factored it. So the only difference between the original problem and this part of the problem right here is this denominator has been factored. Now, I see that the first term has a denominator of x plus 3, the second term has a denominator of x minus 5, and the third term, the equals term, has a denominator of x minus 5 times x plus 3. So, the equals term has both binomials as its denominator. So that tells me my least common multiple, okay, is the two binomials x plus 3, x minus 5. So that's what I'm going to multiply the entire term by. Because remember, the key is I want all the denominators to go away. So now that I'm going to do that, it's like I'm going to do this big distribution. This is going to go there, and it's going to go there, and it's going to go there. Now, at every single term, something's going to cancel. So on this first term, it's going to be the x plus 3's that cancel. So the only thing left would be 6 times the x minus 5. On the second term, it's the x minus 5's that cancel, so it would be 11 times x plus 3. Now for this equals term, the third term, both binomials would cancel, the x minus 5 and the x plus 3, so I really wouldn't have to multiply the 23x by anything. So now, as you can see, all the denominators have canceled. So it's just now going to be an algebra 1 problem. So 6 times x would be 6x minus 30 plus 11x plus 33 equals 23x. On the left-hand side, I'm going to clean up by combining like terms. 6x plus 11x is 17x. Negative 30 plus 33 would be plus 3 equals 23x. Almost there. I think it's a two-step algebra problem at this point. I'm going to subtract 17x. And I've got 3 equals negative, I'm sorry, it's positive. Positive 6x. Okay. So 3 equals 6x. I'm going to divide both sides by 6. And I'm going to end up with x equals 1/2, 3 over 6. Okay. Now, the one thing I would do is I would go back to the beginning of this problem and check for any extraneous solutions or restricted values. If you go back and you look at the factored form of the problem, we know that x cannot equal negative 3 because that would produce a 0 right there, or positive 5 because that would produce a 0 also. Our one and only answer was neither of those two numbers, so we're good. X equals 1/2. Problem 28 and problem 30 come from our statistics unit. So let's look at problem number 28. If we were given this as our 5-number summary, and the problem also told us that there were 22 pieces of data in our data set. 22A asks us, this median of 15, do we know for a fact that 15 was one of the numbers in our data set? So what we do is we take the number of numbers, which was 22. The formula says to add 1, so it's n plus 1 divided by 2. So now we're at 23 over 2, which is 11.5. Now what that tells us is this median right here, the median of 15, is the average of the 11th and the 12th piece of data in our data set. So we don't know for sure whether there really was a 15. If the 11th piece of data was 15 and the 12th piece of data was 15, then that would give us a median of 15. But it doesn't have to be like that. Another thing could have been the 11th piece of data could have been a 14 and the 12th piece of data could have been a 16. That would have also given us a median of 15. So the fact that the median is the average of two numbers, we really don't know if for a fact. Okay. Is the median 15 definitely an element of the data set? No. It might be, but it's not definitely. Now, the D part of this problem said check for outliers. So we're going to do the procedure to check for outliers. And I've already started it right here. It's Q3 minus Q1. So 16 minus 12. So the interquartile range is 4 times 1.5, which is 6. Now you're going to take that 6 and you're going to do two things. You're going to take the first quartile number, 12, and you're going to subtract that 6 and you're going to get 6. That's my low boundary. Now, you're going to take that Q3, which was 16, and you're going to add 6, and you're going to get 22. And that's the high boundary. Now, these are fences. Think of these as fences. Is there any piece of data that is higher than 22 in this data set? Well, there can't be, because the 5-number summary tells us the highest piece of data was 21. Now down here, the low fence or the low boundary was 6. Is there any piece of data in this data set that is below 6? Well, the minimum is. We know for a fact that there's at least 1 point, and it's the number 3. So 3 is a low outlier. Now, you'll notice I didn't do B and C. The reason I didn't do B and C because the numbers are a little bit ugly, but let me show you the main idea of what B and C are. The main idea of B and C is that a 5-number summary or a box and whisker plot breaks the data up into approximately 4 sections. The lowest number to the first quartile is approximately 25% of the data, as is the first quartile to the median, as is the median to the third quartile, as is the third quartile to the max. But since they said n equals 22, if you divide 22 into 4, you don't get a nice even number. You get 5.5. So theoretically, the answer to B and C are 5.5. But that doesn't make sense anyway. So just giving you the main idea of B and C. Problem number 30 asks us to find the standard deviation in 3 different ways. Now, the first one is using the formula. Variance equals the summation of the x minus x bar squared divided by n. So if you did the chart, which we're going to have to do down here, okay, this would be the sum of the last column. And they gave us that. They gave us the fact that the sum of the last column was 88. So all we're going to do is substitute. And we're then going to divide that by the n, which they also gave us. So 88 over 8 equals 11. So now we know the variance equals 11. But they didn't want to know variance. They wanted to know standard deviation. So the standard deviation is going to equal the square root of 11, which is approximately 3.3. Now, the B part of the question said, well, what if you knew the variance was 49? What's the standard deviation? Well, the standard deviation would simply be the square root of the 49. So the standard deviation would be 7. Now, the C part of the problem gave us a data set. It gave us 8 numbers. So in order to find the standard deviation, we're going to have to go through that process of completing this chart right here. And the first step is finding the mean. Now remember the x bar, the mean, is simply the sum of all the data set points, which I've already done, which is 84, divided by 8, which is 10.5. So that's the mean. So I'm going to put 10.5 on every one of these right here. And 10.5. Okay. Now the next column to fill out has a heading of x minus x bar. So I'll do this one. What we're really doing is 3 minus 10.5, which in this case equals negative 7.5. I'm not going to do it for all the others. I have the numbers here right beside me. So this one's negative 6.5. This one is 0.5. This one's also 0.5. This one is 1.5. This one's 3.5. This one's also 3.5. And the last one, 15 minus 10.5, is 4.5. Now, this column is simply x minus x bar squared. So it's every difference that we found squared. Now, I've done this already too. This is 56.25. I've got 42.25 here. I've got 0.25, 0.25, another 0.25. I've got a 2.25 right here. Okay, 3.5 squared is 12.25. Another 12.25. And then the last one down here, 4.5 squared, is 20.25. Now the process at this point is add up all the numbers in this last column, and they add up to 146. Okay. Now the variance would equal 146 divided by the number of numbers, which is 8. So that would equal 18.25. That would be our variance. But the problem didn't want to know the variance. It wanted to know the standard deviation. So the standard deviation would equal the square root of 18.25, which is approximately 4.27. And if they only wanted one decimal place, it would be 4.3. Problems 32 and 34 also come from our statistics unit. Problem number 32 says that the apartments in the area of Fairfield University, the rent follows a normally approximate curve, a normal curve, the bell shape, with a mean of $1,800 and a standard deviation of $130. So if your apartment that you share with your roommate is $2,000 per month, what is your apartment's z-score? So we're just going to follow the z-score formula. Z equals x, which in this case would be $2,000, minus the mean, which is 1,800, divided by the standard deviation of 130. We know for a fact your apartment is more than the average rent. So we know it's going to have a positive z-score. So 2,000 minus 1,800 is 200 over 130. So 200 divided by 130 is approximately 1.54. So that's your z-score for your apartment. Now what that means is your apartment is 1.54 standard deviations more than the average rent. Okay, problem number 34. Given a 5-number summary, is 40 an outlier? Should the number 40 be considered an outlier? Well, the only way we're going to know is check for outliers. We're going to take Q3 minus Q1, which is the interquartile range, and we need to multiply it by 1.5. So 26 minus 18 is 8 times 1.5, which equals 12. Now really they only asked about the number 40, so we really only need to check the high boundary. So we're going to take the Q3, which is 26, and we're going to add the 12, and we're going to get 38. That's the upper or the high boundary. And since the number 40 is more than the number 38, then yes, 40 is an outlier. Okay, and that completes the even problems that are more algebraic in nature and don't require graphing. We'll now move on to the problems that do require some graphing. Okay, now we're going back to some problems that require graphing. So 36, 38, and 40. Let's start with 36. If this were the function right here, let's sketch the graph. So the first thing we have to figure out is, of all the different functions we've learned, which one is this? And this one's a quadratic, so it's definitely going to be a parabola. Now, the key point on a parabola is its vertex. So the vertex of this parabola is opposite of that, same as that, so -5, -2. So we're just going to sketch it. We're going to say we need to go left 5 to get to -5. So 1, 2, 3, 4, 5. So let's say we're right there. And then we need to go down 2. So let's say we're right there. -5, -2 takes us about to right there. Now, the -4 is the initial rate of change. -4, it's not a slope because a parabola is a curve. But to find the next 2 points, we could just go over 1 and down 4, which would put us about right there, over 1, down 4, which would put us about right there. Okay. And now, let's make a parabola out of this. So we're coming up, we're turning right here, and we're going back down, and so, yeah, that's not bad. I've probably done better, but I've also probably done worse. So there we go. There's that parabola. It's a down, skinny parabola. And I think that's all we needed on problem number 36. Sketch the function. We could do a thing, the vertex. Remember how -5, -2 was the vertex? We could identify it, since it's a down parabola, the vertex is a max. So the maximum point, the maximum height of the parabola is -2. Now, problem number 38 just generically asks, what does the range mean? Well, the range means all the y values that are used on the function. So problem number 40 goes back and says, well, what is the range of problem 36? What are all the y values used on problem 36? Well, since it's a down parabola, okay, the lowest y value on this parabola is going to be -infinity. However, there is a maximum. Okay, the highest point on this parabola occurs at -2. And so that would be the range. Okay, problem number 44 asks you to write the equation of the function that they show you. They clearly show you an absolute value function. We need to know the vertex, so it's easy to see on the graph that the vertex is 0, 4, and we need to know the slope. And the slope appears to be down 1 over 2. And so knowing all that, we can write the function as f of x equals, or y equals. Okay. Now, the slope is going to be the leading coefficient, -1/2. Absolute value functions use the absolute value bars. Now, since the x-coordinate of the vertex is 0, I could either put x plus 0, or I could just put x, either one. I'll do both of them. Okay? And then since the y is 4, we're going to put plus 4. Now, since it's going to be a multiple choice question, I doubt if you're going to see it like this. You're going to see it like this, -1/2. And then all you're going to see is the absolute value of x. You're not going to see x plus 0. And then you're just going to see the plus 4. So f of x equals that equation. All right, problem number 46. Sketch this particular graph. Now, the function is negative x plus 1 squared times x minus 6 squared. That tells us we have a couple of zeros. Okay? Our zeros are at -1 and +6. So those are going to be our x-intercepts. -1, I'm going to just put it right there, and +6. I'm going to put it right there. Now, the next thing we need to know is the end behavior of the graph. Okay? My highest x power, if I multiplied all this out, which I'm not going to, would be x to the 4th, because x squared times x squared is x to the 4th. But there's that negative sign right there, so it would be negative x to the 4th. So my characteristics are it's negative, but it's even, so it would be low to low. So my function is going to start low, and it should end low. Now, one more thing about these zeros. Notice this is a double, and this is a double, which means at both of these points, it's not going to pass through, it's going to bounce. So everything should work out okay. I'm going to come up. I'm going to start low. Remember, low to low. I'm going to start low. I'm going to come up. I'm going to bounce when I get there. At some point in time, I'm going to turn around, and I'm going to bounce again. And there's the sketch. Make that a big point. Okay. There's my sketch of that graph. Okay, problem number 48 is another sketch problem. Okay, sketch that function. Sketch that rational expression function. Well, the first thing we're going to need is we're going to need asymptotes on this one. So my asymptote, one of my asymptotes gets shifted 6 to the right. So that means my vertical asymptote, which is usually the y-axis, gets shifted to the right 6. And then my horizontal asymptote is going to get shifted down 4. So both of my asymptotes are going to shift. This one is going to go 6 to the right. So let's put it way over here. Okay, that would be x equals +6 if we needed to know what the equation of it was. And then my horizontal asymptote, which would normally be the x-axis, is shifted down 4. So let's shift it down 4. That would be y equals -4. Okay. Now it's simply time to sketch what this graph might look like. Well, because this is a 2, it isn't just going to go out 1, up 1. It's going to push out a little bit further, but it's basically going to do the same thing. It's positive, so it's going to do something like this. And the other key point would be down here somewhere where it makes the turn, and it's going to do something like this. So that would be a decent sketch of that function. So for problem number 50, we want to sketch this function also. Now, as you can see, it's an exponential function. So exponential growth. Now, the exponential function is the only one that on the parent graph, the key point was not 0, 0. On the exponential growth, it was 0, 1. That's the key point. Now, the first thing we have to do is look at the shift. Okay? Since there's nothing up here with the x, there is no left-right shift. The only shift that's happening in this function is the plus 3, which means we're going to go up 3. So that means the key point is going to shift up 3. So it isn't going to be 0, 1 anymore. It's now going to be up here at 0, 4. But remember, something else shifts also. Remember that asymptote. There's an asymptote right here. Well, that asymptote has to shift up 3 also. So what used to be the asymptote on the x-axis at y equals 0 is now up here at y equals 3. So the asymptote shifted as well. So now we're at y equals 3 as an asymptote. Now the shape stays the same. It's still an exponential growth graph. So the graph, doesn't cross the asymptote. It just it's really close here. It crosses at the key point, and then it goes up like that. So a sketch of the graph would do something like this. Going through that key point of 0, 4. And then the last problem, problem number 52, asks for an explanation of a relative maximum. Well, in order for a relative maximum to occur, the graph has to be increasing up to a point, and then it immediately has to turn around and decrease. So on problem number 52, this would, here, I just made a sketch as an example. This would be a relative max right here. It has to increase up to the point, and then it has to immediately decrease.